Dear students, this session is regarding three-phase unbalanced delta connected load. What is three-phase unbalanced circuit? An unbalance exists in a circuit when the impedance in one or more phases differ from the impedance of the other phases. In such case, line or phase currents are different and are displaced from one another by unequal angles. However, the source voltages are assumed to be balanced. If the system is a three-wire system, the currents flowing towards the load in the three lines must be added to zero at any given instant. Or if the system is a four-wire system, the sum of the three outgoing currents is equal to the return current in the neutral wire. Now let's consider a three-phase unbalanced delta connected load. This is a unbalanced load. So the impedances at different phases are different. This is R, this is Y, this is B. R, Y, B. This impedance is Z1 angle phi 1. This is taken as Z2 angle phi 2. This is taken as Z3 angle phi 3. 9 to Z1, Z2, Z3. Okay, now let's mark the currents also. The currents through the lines are marking first I1, then this is marked as I2, and this current is taken as I3. Now let's consider the phase currents. I'm marking the phase currents like this. I'm naming this current as IRY because it flows from R to Y. So I have given the name IRY. Then current through second phase direction is marked like this. It is IYB. Current through the third phase magnitude is marked like this, and this current is taken as IBR. Now we have to check the phase sequence. The phase sequence may be RYB sequence or RBY sequence. The line voltages VRY, VYB, VBR. The phase sequence is considered as RYB. We have to consider the voltages like this. VRY is V angle 0 degree volt. VYB lags VRY by an angle 120 degree, and VBR lags VR by Y by an angle minus 240 degrees. So if the phase sequence is RYB, the line voltages should be considered like this in this sequence. If the phase sequence is RBY, voltages should be like this: VRY, VYB, and VBR. VRY, if VRY is V angle 0 degree, VBR lags it by 120 degrees. So VBR should be equal to V angle minus 120 volt, and VYB should be equal to V angle minus 240 degree volt. And here in the given question, here we are considering RYB phase sequence. So let's take the voltages like this and continue. Let's first consider the phase currents. The first current IRY. IRY is the current from the terminal R to Y. So IRY will be equal to voltage between terminal R and Y divided by impedance at that phase, which is Z1 angle phi 1, which is equal to VRY is V angle 0 degree. So magnitude of this current will be V divided by Z1, and phase angle of this current is 0 minus phi 1. So this will be IRY. Then we have to consider IYB and IBR also. IYB equal to VYB divided by phase impedance in that phase, which is set to angle phi 2. And VYB is V angle minus 120 degree. So it is V angle minus 120 divided by Z to angle phi 2. Magnitude is V by Z2 and phase angle is minus 120 minus phi 2. Then we have to write the current IBR also. IBR equal to VBR by Z3 angle. Now we have to write the equations for the line currents. The line currents are I1, I2 and I3. So let's consider I1. If we apply Kirchhoff's current law to the terminal R, to the node R, we can write the expression for I1 as I1 is equal to IRY minus IBR. Similarly, if we apply Kirchhoff's current law to terminal Y, we will get the expression for I2 as I2 equal to IYB minus IRY. Similarly, if we apply Kirchhoff's current law to the terminal B, we can write I3 equal to IBR minus IYB. While considering or while taking the difference between the phasors, you have to consider the phasor difference. This should be the phasor difference. Phase angle should also be considered. Now let's move to a problem. Three impedances Z1, Z2, Z3 are given. Are delta connected to a 400 volt three-phase system as shown in figure. Now we have to determine phase currents, line currents and total power consumed by the load. Figure is redrawn and all the currents are marked like this. Here Z1, Z2, Z3 are given. Z1 equal to 20 angle 30 degree in polar form. If we are writing it in rectangular form, we will get it as 17.32 plus J 10 ohms. Similarly, Z2 and Z3 also we have to convert into rectangular form. Now let's write the current equations for the phase currents. The phase currents are IRY, IYB and IBR. Now let's first consider IRY. VRY divided by Z1 equal to, here we are considering RYB phase sequence. So VRY is V angle 0, 400 angle 0 degree divided by Z1 is 20 angle 30 degree. We will get it as 20 angle minus 30 degree amperes. Then we have to find out IYB and IBR also. So we got the phase currents like this. Now we have to find out the line currents I1, I2 and I3. In order to get I1, I2 and I3, we have to write the equations for I1, I2 and I3. I1 is equal to IRY minus IBR, that is equal to 20 angle minus 30 minus IBR. We got IBR is equal to 40 angle minus 150. That is equal to, you can use calculator for finding out the result, 52.91 angle 10.89 degrees. This much ampere. Similarly, we can write the currents I2 and I3 also. I2 is equal to IYB minus IBR. IYB is 10 angle minus 180 minus IBR is, it's not IBR, IRY. Angle minus 30. This is equal to 29.09 angle 159.89 degree amperes. Then we can find I3 also. I3 we will get it as 31.73 angle minus 140.93 degree amperes. Then we have to calculate the power consumed. In the question, it is asked that to calculate the power consumed also. So we have to calculate the power consumed. Here we are having 3 phases. So we have to consider power consumed in all the 3 phases. Power in phase 1. Current in phase 1, which is IRY square into resistance in phase 1. That is equal to IRY, we got at 20. So 20 square into R1 is 17.31. We have find out value of R1 here. This is R1, X1, R2, X2, R3, X3. R1 is 17.32. Equal to 6,928 watts. Similarly, power in phase 2 and phase 3 should be calculated. Then total power consumed is the sum of these 3. 8,928 watts. The total power consumed. Okay, thank you.